be doing tangent inverse here, like we have been. P equals R cosine, as I said, it's already at the top, theta minus phi. So we really only have to find two things. Let's do the first example here. Some of this is going to look familiar because a lot of the steps are similar to things we've done before. So if you were okay with it before, you'll probably be fine with this. All we really need to fill this in is the values for phi and p. Remember, the r and the theta make it polar form. Remember that from the last section that we did? Does anybody remember how we found p? You've done that before. When you had a rectangular equation like this, do you remember what you did? That's how you found the angle. But not quite. We're headed there. First, you have to get it equal to 0. So you're going to have that. And then, excuse me, we had to do this. We had to do the square root of a squared plus b squared. See, this is in standard form. ax plus by minus c. Then, let's go ahead and do that. So we got 5 squared plus 12 squared. This is your a and b. This one comes out nicely. It's Pythagorean triple. Now remember, it was plus or minus, and how did we decide what to divide by? Now we have to divide everything by it. That's right. Whatever this is, you do the opposite. So we're going to use a positive 13. Remember that? We did that on a quiz a couple of weeks ago. So we use the positive 13. And we're going to divide everything, so I need to erase this a and b. If you simplify, you probably don't remember what form this is called. It's called the normal form. Do you remember p was the distance, right? So, you're all looking at it funny. Do you have questions? Which one? Oh, yeah. Sorry. Didn't write the one. Thank you. Now, do you remember when you did your quiz, this was p, wasn't it? Well, then we found p for this formula. See, we're trying to find p and theta, or excuse me, phi to put in here. Now, you knew how to find phi before, too. You said it. Tangent inverse, but you couldn't do that yet until you got it in normal form, because the signs might change. Now, they didn't, because we divided by positive 13. But if we had to divide by negative 13, these would have became opposite, and you got to know which quadrant you're in. Remember that? I don't know if you remember that or not. All right. So really, what you're going to do here now is take the tangent inverse of 12/13 over 5/13, because this is the same as y over x, sine over cosine. But don't the 13s cancel? So you're taking the tangent inverse of 12/5. go ahead and do that on your calculator, scientific calculator, see if you get what I got. Let's round this to the whole degree. Anybody done it yet?
Yeah.
What'd you get? 67 degrees. Now, I've found phi, and I found p is 2. That came from here. Now I can just write my equation. But how do I know this is my final answer for the degrees? Remember, it's your reference angle to begin with. You've got to figure out which quadrant you're in. What do we look at to see what quadrant we're in? Yes, A and B. Here, remember, once it's in normal form, isn't it positive, positive? Remember that? X is positive and Y is positive, so we're in the first quadrant. So 67 is the degree measure. Otherwise, it's a reference angle if we're in a different quadrant. So now we can write our equation. So we replace P with 2 equals R cosine theta minus 67 degrees. Now there's the polar form of that line, polar equation of that line. Yes? It's never negative. And that's something y'all missed on your quiz, and I said it 100 times. You're pulling it out of the formula. The normal form has this minus always. P is just this number. And the reason is P is a distance. You don't have negative distances. It's the distance from the origin to the normal. You've probably forgotten all that. But anyway, there is your final answer. So I want you to try on your own B down there. See if you can write the polar equation for that linear equation. Okay, how many got plus or minus square root of 53, right? Okay. Do we use a positive or negative? Negative. Since C is positive, we got to use a negative. Always use the opposite of C. Negative. So what is our P? Five square root of 53 over 53. How many had that? Okay. Remember, you got to rationalize. So we can write our formula so far. put that in for P. All we need is our angle, and we have the polar form of that linear equation. So what are we taking the tangent inverse of? 7/2. You'll notice this happens all the time. These things always cancel, the denominators. You can almost always look at those two numbers and know what you're putting over what. If you do it the normal way, it'll still cancel out and put 7/2. So you got tangent 7/2. The negative is incidental. That doesn't mean you really need to use that to figure the tangent, because how do we figure out what quadrant we're in anyway? Yeah, don't we look at the plus negative for that? So you don't really need it to find your reference angle. So what is the reference angle here before we get our final? What do we get? Is that what everybody got? Okay. Now what do we do with that? What quadrant are we actually in? I think we're in the second. I think we're in the second quadrant. How many know we're in the second quadrant? Negative, positive? Remember, you don't look up here. That's what some of you are looking at. You always look at your normal form. Everything comes from this. You do not use this. And if you get, I use this sometimes because this is easier to work with. But even if I do use this is a negative and this is a positive because there's two negatives there. So what's the final angle? What do we have to do to get our final angle if we're in the second quadrant? Subtract from 180. Right? If you're in the second quadrant, your reference angle would be here. Always on the x-axis. So we want this one. So what do we get? 106. And you have your polar form of that linear equation. How many got that right? Give yourself 2 bonus points. Now we're going to go the other direction. So let's go on the next page behind this one. We're going to be given the polar linear equation, and we're going to write the rectangular. Here's what we're going to use. Something from the past, and the book doesn't use this. I don't understand why they don't. This is a quicker way than they show how to do it. They use the difference identity for cosine, which still works, but this is simpler. Write this down and you'll use this. Do you remember this form we did when we were finding the rectangular form? And it's been a while. Remember how this was your normal form, standard normal form. So we're just going to use this. Now the original equation we're given, we have, what are we given in this one? 2 equals r cosine theta minus 60 degrees. Well, what are we given here that we can plug in there? Isn't 2 your p, right, from what we did on the first page? This is p equals, isn't it? So you can just plug that in there. It just goes right in here for p. And what can we use this to do? What was this in the general equation? This was theta, wasn't it? Well, don't we have thetas? So now we can plug those in, get values for them. So you'll have x cosine 60 plus y sine 60 minus 2. Let's write this a little closer together. Now we need to find the answers to sine and cosine of 60, simplify it, get it in standard form, and then we have the rectangular equation. Got to use your special triangles. What's the sine of 60? No. Have we forgotten all we learned first semester? What's the sine of, or cosine of 60? 1/2, isn't it? Here's 60. Isn't 1 adjacent hypotenuse? So this would be 1/2 x, right? Cosine of 60. Now, what's the sine of 60 going to be? Square root of 3 over 2. Opposite over hypotenuse for sine. Now on your quiz, you've done a little bit of this before. I don't like that left that way. Math books don't leave it that way. We don't want fractions, we want integers or simplified radicals. So what would I do to get that in another form? Thank you. Multiply everything by 2 to get rid of the denominators. Now you're really multiplying both sides, but 0 times 2 is still 0. So this would be x plus square root of 3y minus 4, wouldn't it? How many remember doing this before? Yeah, we did. That's why I prepared you with that section. A lot of teachers skip that section on the normal line, but that gets you ready for this. Okay, and that's what we wanted. We went from polar. That's your final answer. This was the original. This was the polar form of a line. This is the rectangular. So that's your answer. You want to try number 4, or excuse me, part B? Try that one. See if you can write that one. This time it's in terms of pi, but you can change that to degrees when you're trying to find your sine and cosine, if you remember how to do that. And you're going to use this again, this normal form. That's supposed to be a minus in that problem, the B there. You see the plus? No, it needs to be a minus though. That missed top. It needs to be a minus. Isn't it a plus there? Or I'm not seeing it right with my glasses. Yeah, the normal, or the polar, just listen. It should be a minus. It's a mistake there. You always have a minus in polar form there. So make that a minus there. That's a misprint. And I know what you're trying to say, Kyle. That would be what we would do, but I don't want to go there right now. Were you saying minus a negative? Yeah. If we were going to do that, I don't want to do that, though. I don't want to go that direction. I want to keep it straightforward right now. what are you taking the cosine and sine of? I know it's 5 pi over 6, but what is that? What's the reference angle for that? Say it again. It's 150? Yes. Another way you could look at it, we're really going to take the cosine of 30 as our reference angle, right? And then remember that 5 pi over 6, like 150, puts me in the second quadrant. So what's cosine there? Negative. Well, what I meant was the sine of it. It's negative in the second quadrant, isn't it? So when you take the cosine of 30, which you just said it, what is it again? Somebody said it. Square root of 3 over 2. But it's going to be negative, isn't it? Now, does everybody understand where we got that? We got that from your special triangle, like I had on the board earlier. Yeah, cosine of 30 is adjacent over hypotenuse, but cosine 5 pi over 6 tells us we're in the second quadrant. All right, what's the sine of 30 going to be? 1/2, and it's positive, isn't it, in the second quadrant? So that'll be plus 1/2. How many got this so far? Okay, and then you know how to clear the fractions, and you'll have your final answer. So what is our final answer? Don't forget your x and y's, or it's not an equation. Plus y minus 8 equals 0. How many got that right? Okay, 2 bonus points. Now, normally I like to have my first term positive, so I probably would go ahead and change everything to its opposite. Still correct this way. Okay, give yourself 2 if you got that. Now we're going to have to do something that's a little different. We're going to graph a polar equation. And you see that at the bottom down here on your paper. Let's see if I can figure out which one I want here. Won't let me do it. Okay, that's the first one at the bottom, isn't it? Is that what you got? Okay. Now, I'm going to be nice to you on the quiz I give you. I'm going to give you values to put in, because some people have trouble figuring out what to use. But this is your equation in polar form, and we want to graph it. Now, these are all linear equations, so when you graph this, your points should make a line. Otherwise, you're making a mistake. It should make a straight line. Very straight. Now, the best form for this, here's what we need. We need r comma thetas. We learned how to graph those in the last few sections. Well, the best way to do that is find this equation and solve it for r. So since r is times that, I'm going to divide both sides by this so that I'll end up like this. R equals 1 over cosine theta plus pi over 3. Now in this case, we're using a plus because we're not changing it. I'm not worried about it being a plus. We're just going to use it in this form. Now does everybody see what I did here? I'm just dividing both sides by the denominator, or by this. So I can have r solved for. Now the reason for that is so I can get values here. You need to have at least 3 points to graph the line. So you might want to write those down. You're going to have 3 ordered pairs. Now, does anybody know why I would want to use 3 instead of just 2? 2 is enough to draw a line, but what's the third pair going to do? Can't think of a logical reason why I'd make you do 3. What if your second ordered pair is wrong? Aren't you still going to have a line? If you just do 2 points, you're going to have a line, aren't you? But what if one of those is incorrect? Are you going to know it? What will the third point do? It'll confirm whether you got a line or not, because it has to be on the line. Are you following my thinking? That's why I want 3, not just 2. You need to confirm that your other points are on the line by doing that. So you need 3. Now, when you pick values for theta that we're going to plug in here, notice we have pi over 3, which is a familiar degree measure, isn't it? What is pi over 3? 60. So since that's 60 or pi over 3, I want to keep it on these increments so it's easy to graph. So you can plug anything you want in here. I think the first one I used was 0. 0 pi. Okay? So if I put 0, and it's going to look kind of weird. We're going to use theta. We're going to put a theta in first here, and then find r. So if I put 0 pi in here, and this is going to take up room here. I don't know if I have room to do all of them. I may have to erase it as I go here. But here's what you're going to have. Cosine of 0 pi plus pi over 3. Right? I'm putting 0 pi in for theta. So isn't that 1 over, what's 0 pi plus pi over 3? Pi over 3. So I'm 1 over cosine pi over 3. Are you with me? Now what's that value? That's cosine of 60. What is that? 1/2? 1/2? So now I have 1, and this is where people forget. It's on the bottom, so I have 1 over 1/2. What does that equal? 2. Remember, you multiply by the reciprocal when you divide by a fraction. So this is 1 divided by 1/2, which is the same as 1 times 2, which is 2. So we found the r for this is 2. By putting 0 pi in, we found our r. Let's graph that point now. Go ahead and graph it. You're supposed to know how to graph these from the last couple sections we did. That one's easy, isn't it? Here's 0 pi, same as 0 degrees, and we'd go out to stay on this ray. So we'd be right here, wouldn't we? Everybody okay with that? All right. Now another value you can use. Let's see if this works. Yeah. Let's use 2 pi over 3. Now why did I choose that? Plug it in. When you plug it in, what do you get? 1 pi. You see, that's how I pick my values. I'm going to pick increments of thirds, so I'm going to get easy ones to graph. So if I put 2 pi over 3 in here, so we'll erase this. Now we're going to put 2 pi over 3 in here. And remember, you're always going to, not always, but in this particular problem, you're going to have 1 over. So if I put 2 pi over 3 in here, 2 pi over 3 plus 1 pi over 3 is, isn't that just pi? 3 pi over 3. Pi. You see what I'm talking about? You all right, Nika? Remember, this is a 1, so 2 plus 1 is 3. 3 pi over 3 is 1 pi. So, what is the cosine of pi? Who said that? Who said 1? Sorry. How does he know it's 1? Does everybody know how he got that? Unit circle. Where? No, it's -1, isn't it? If you go to pi, what's the ordered pair there? -1, 0, and cosine is always x. So this would be -1, wouldn't it? So when we put that in, what do we get for our r? It's like we get -1, don't we? Yes? Now graph that. What's 2 pi over 3 the same as in degrees? 120. Very good. But since it's a -1, See here we're going to go to 120, same as 2 pi over 3, but since it's negative 1, don't we go this way? Yes? Remember that? Now, I'm going to do a third point to confirm that I'm correct. The next point I do should end up being on the same line as those two. So let's see what I got here that made it easy. Let's see, have we tried, let's do negative pi over 3. You can choose negative angles. Why would that make it easy? Yeah. If I put negative pi over 3, then I'm going to be taking the cosine of 0 pi, aren't I? So we're going to put negative pi over 3 here, which means now I'm going to take this cosine of 0 pi, which is, what's the order pair at 0? 1, 0, so cosine is 1. So 1 over 1 is 1. Now, oops, look what happened though. Isn't that the same dot?
Yeah.
So that means I need to pick another one. I need a third point. Let's see what else I chose here. Now I do that on purpose because you're going to run into that and you need to have 3. How about, let's see, we did negative pi over 3, 0. See, what else did I use here? It's like I used pi over 6. Have we done pi over 3? Oh, we haven't done pi over 3. Let's do that. Let's do positive pi over 3. So if I put positive pi over 3 in here, then we end up with the cosine of 2 pi over 3, which is really the cosine of what? No, I just want the degrees for this. It's a positive 120, isn't it? Which means I'm going to do the cosine of 60 degrees and it's going to be negative because we're in the second quadrant. So what's the cosine of 60? Isn't it 1/2? So in this case it's going to be negative 1/2 because we're in the second quadrant. So what's 1 divided by negative 1/2 going to be? Negative 2. So go to pi over 3 is the same as what in degrees? 60, which would be here, but I don't want to go, I have to go negative 2, which means I've got to go which direction? This way. And now do you see how I found another point that's going to be straight in line with the other two? Then you draw your line and you're done. Because that's not the point. We're trying to graph with polar equations. We're trying to learn how to do polar points here. And my calibration's off. And since this is a line that goes on forever. This is the one that most people have trouble with doing, but like I said on your quiz, I'll give you the or the theta values to make it a little easier for you. So you'll be able to find, you still got to be able to plug them in fine. All right, that's all we need to do today. I'm not going to make you do the last one there. If you want to try it, I've got it on my sheet. You can check it. But we are done. That doesn't do that here.